Hello and welcome to our Design for FDM Technology webinar series. It's a pleasure to have you all here with us today. As usual, we try to be short and precise to deliver a good overview over a complex topic. Just for those of you who are new and don't know the rules here in this webinar, all attendees are on mute. If you have questions or something, feel free to type into the questions tab your question. We will have 2 spots during the session where we will answer the questions. So feel free to use that. If you haven't attended the first 2 parts of this webinar, it's not a problem. All the recordings are available on the Stratasys Academy for you to view them later on. Just as a short reminder, this is the 3rd part of our webinar series. So the last part. In the parts before, we have talked about the basics of FDM. Then in the second one, the design considerations about FDM, and today we talk about advanced FDM. So that you know who is talking actually to you. My name is Michael. I'm your host. I'm the knowledge and training lead for PolyJet here at Stratasys EMEA. And our expert, Carolus, he's the knowledge and training lead for FDM, and he will guide you through this webinar. And of course, he can tell us now what we're gonna expect today and a short recap of what have been done in the last webinar. Carolus, up to you now.
Hello, Michael. Good afternoon and welcome to everyone who joined this webinar session. Today, we will speak about further design modifications, which should help you to manipulate different regions of the model. Also some post-processing considerations in the end. So, to summarize last sessions, we spoke or I showed you that using native CAD files when working with the GrabCAD Print software can really help you, and you will see today what I mean by that. But before, we can say straight that you can save additional step in your FDM process with using CAD files and do not need to translate them to STL files. You should consider the printing orientation. By changing this, you can improve strength, speed, or quality of your models. You maybe remember that slice height affects toolpath thickness and it affects minimal wall thickness, which is slice height 2 times will be the toolpath thickness, and 2 times the toolpath thickness will be recommended minimal wall thickness. When designing, you might want to search for possible self-supporting angles to save time and costs. Remember, the clever usage of chamfers would improve this greatly. Also, we learned that you can section parts, you can improve printing time, the strength of some areas if you do that, or you might want to section the parts to preserve smaller features in order not to get them damaged in later post-processing. So today, on our agenda, we will talk about infill, we will talk about variable density parts. I will show you some examples with GrabCAD Print. What do I mean by that theory? And we speak about post-processing and texturing in the end. So FDM is unique in how we can manipulate part density and make one-off lightweight parts quite quickly and inexpensively. By default, normally we have solid settings applied to the part, but it also has the highest build time, material costs, and obviously the weight, which might not be a great solution for very large parts, or if you're trying to save some times and costs and weight. Using different settings on GrabCAD Print, we can change the density of the part. We can also change the thickness of the surface or a body, for example, or even using different bodies to assign different densities to the whole part. So let's look about what infill styles we have. So we have solid, hexagram, sparse double dense, and sparse infill styles as default. So solid is best used for maximum strength, obviously, when the model is used for a long time or to take a lot of repetitive stress. Hexagonal is something like a best combination of strength and material usage. Sparse double dense is usually to print faster with also quite a good strength, and the fastest printing time will be gained by using the sparse infill. It's also be gain the least amount of material printed, and when the strength is not a primary concern, models need to be just for sizing, brainstorming, or looking at the outside shell, you can use sparse infill. So let's briefly remember the topic about X and Y holes from the previous session. We learned that if we want to have perfect holes, if you absolutely need to have perfect holes, we have to drill them after the print, right?
But Carolus, one question: what if I have selected a sparse infill and I drill that? Will it not be drilled into the sparse?
That's a very good question, Michael. So, of course, with the default settings, we have only 2 contours around the holes, and you need to add stock for drilling and provide strength to the final hole. So without to do that without drilling into the sparse filling, if we choose this. So what you need to do is basically add around 3 to 5 contours, or usually 2 and 3 millimeters around the hole in order not to get into the sparse filling.
Oh, thank you. Nice answer.
No problem. Before we move further, I would like to ask audience a question. So it is interesting for me, have any of you used GrabCAD Print's functionality to create variable density parts? So 3 possible answers. One person, you never heard of this term, which we look into on the next slides. You've heard about it, but you would like to learn how this functionality actually works. Or you are an expert and you are creating variable density parts all the time. So Michael, if you can help me and start the poll, I would like to see the audience answers.
Okay, I launched a poll. Please be aware, if you are in full screen, you might not be able to click on the answers. So you have to go out of full screen mode to answer here.
All right, so look at the poll. Okay, we see a majority of people just looked and would like to learn about this functionality. Actually, we have 20% of people who are already using it, so that's great. I'm really happy about that. Probably a couple of few seconds. Maybe Michael, you can share the results if possible.
Okay, I'm gonna stop that now and share the results. Here we go.
All right, so we see that majority of you would like to learn more about this functionality. Some of you are already using variable density parts. That's great. I hope that something what I show you can learn something from that. But I'm really happy to show for the majority to these possibilities what we are able to do. So let's get back to the presentation. Thank you, Michael. So a unique feature of GrabCAD Print is that a single part can have regions with different infill styles, and this is only possible when you're using original CAD data. So original CAD files. If you would have to use STL files, then this possibility is not there, either using GrabCAD Print on or inside. So unlike default interior styles such as solid or sparse that are applied to the entire part, variable densities allow a single part to have combinations of solid and sparse styles. When designing, we have to create separate bodies where each region's density can be adjusted independently. So as you see from this example part, the blue area there is an additional body created within the part, and these two separate bodies we can adjust independently. So as an example, we can take handed tools which are used on the factory floor, car manufacturing. So in this case, it's an assembly line of a car manufacturer. They produce thousands of cars per year, and a human operator has to lift such tools into place hundreds of times. So this fixture originally consisted of many out-of-the-shelf parts, which might have sharp edges. It weighed around 6 kilograms. So such fixtures put operators at more risk of repetitive injuries or damaging the vehicle, and also slowing down the production times. By using clever design and print settings, the weight of the tool was reduced to 4 kilograms. So if you have to lift it up multiple times a day, it's already 2 kilograms. It's quite a weight saving. The routes of all hoses and tubes were also optimized. Design, handles, and placements of the buttons were made, and the tool became more ergonomic. So instead of assembling the frame, and now it can be printed in one piece and saving time and money. But let's see how it was done, or how we were doing that before. The old method to produce those variable density parts was really time consuming, involved exporting multiple bodies as cells separately, adjusting for toolpath widths and adding clearances, processing them inside one at a time by creating custom groups. So it's nearly impossible to make a mix of complex or organic structures, or to create bodies that change profile through the Z-axis. So this is where GrabCAD Print ability to work with native CAD files really shines. It allows users to choose any CAD body or face to apply more infill or contours with just a simple slider. This ability to add extra infill and contours by CAD body or face let us do some unique things with our models, making them strong and tough right where they need to be, and also light and rigid everywhere else. So also, since we're selecting CAD files directly, we can also do such thing as resizing holes to accept the wide library of standard insets, what we already have in GrabCAD Print, without even having to go back into the CAD software itself.
Carolus, how can I select different areas in the CAD file to adjust different densities? Is there a trick, or?
So actually, I will show you an example right now, but before we go into the live demo, I need to say that you need to design the model with separate bodies. As you see in this example, these are separate areas which were changed, and you have the bodies inside of the part which can be changed independently. So with some designing tricks separating the models, having them different bodies, you can change the properties of each body. This is only possible when you're using native CAD files.
Good to know. So before we go now to the live demo, we open for some questions, and we have a few which came in. Carolus, if you feel free to answer, I'm gonna read them. The first one is there an option to calculate cost in GrabCAD?
Well, directly cost, probably not, but what you can do is use estimates when you slice the file, and they will show you, let me just show this beforehand. I will do that in my demo. You see that on estimate, you will have the material consumption, and this is probably could give you a good idea how much it will cost. If you compare the price of the whole spool, then divide it by what you need, and you just, like this, you can have your costs calculated.
Good. I hope
Do we
that
have any
gives the answer. We have another question.
questions?
Yeah, you can do variable density for FDM parts using STL files. IFO, I don't know what that means. I forgot it in Slicer or something like that. Can't understand the.
I think I understand the question. Maybe we'll look afterwards into the question.
Okay.
I can come up to you one by one and answer those questions after the webinar session. So let's start like this. You see the part from the, or do we have additional questions?
No, that's it.
Okay, thank you. So we have the part from the last session, and you see it is separated. Each individual body was separated on the part. We also would have like this to print the part separately, but we don't do that. So we have an ability to have this disassembled or assembled. So you remember the part from the last part. So we need to make it into the one single group. And you can see by choosing different bodies, I can choose different sections of the part. Not also selecting bodies, but showing that we have a real CAD data. We can also go to the model settings right here and click, instead of body, click on face. And now you can also select different faces of the part and apply different settings to those faces. So first thing what we are going to do, you see in the last section, we spoke about this vertical holes here, and that we can make them self-supporting by adding diamond shape. So it's okay when you have 2 or 3, 4 holes. It's quite easy to do that in CAD, but if you have multiple holes and need to do self-supporting, maybe you can leave this task up to the operator in the preparing software to do this for you. So what you can do with this option is when you are selecting the face, you can select each individual hole right here, and with a single click of the button, make self-supporting, updating the geometry. You can make them into the diamond shape and print without any supports. What else you can do? Probably it was the question from the first session, if we can manipulate the seam. So you see that this nice surface where we would need to have a good surface quality. We would like to avoid the seam, which is basically the start and end point of the toolpath, put it on these surfaces. So what we can do is we can select multiple faces and click one button here and tell the software and then later on the printer to not to put any seams on these surfaces. So that means they will be translated into any other surface here. What we can also do when we have this option, we can increase surface thickness if we need to. You remember from the first slide, I show you that for drilling the hole, you probably want to have a little bit of material around it, not to drill into the spot section of the part. So you maybe see from the slide that I used 2 or 3 millimeters around the part. We can just type this value manually, or we can use the slide because it increments according to the slice thickness, and have our hole right thickened and prepared for drilling. So let me show what does it means when we have this thicker for drilling. If we prepare the file, I've done that beforehand to make it a little bit quicker for showing purposes. You can see that by changing the thickness of the hole, we have additional control. So getting back to our model, we spoke that we need we might need to drill that, but what if we are using some kinds of inserts? So in this updated version, I made 2 holes when we want to have nuts inserted into them, and 2 holes just as they are, either for drilling or used as they are. So you can do something like this. You can select again the hole, and for example click apply insert. So as I mentioned before, GrabCAD Print has some library of heat set inserts or helical inserts, which you remember from previous session, we can say threaded inserts. And we have a standards on metric on inches. Of course, in Europe we use metric most of the time, and we can say to choose from M3 to M8. If you need anything different, you can go to the custom insert section and define the dimensions given by the insert manufacturer. So for this showing purpose, we just take the M3 and update it. You probably notice that the diameter of the hole changes itself. But that's not only what the program does for you, it also changes the surface thickness. You see, I cannot adjust it because the value is selected from the library, so surface thickness changes. And if you are using inserts, you can see I changed the settings beforehand. You can also notice that we will have same increased amount of toolpaths later on after the printing. So getting back to our main point of variable density parts, we can also change the density of different regions of the part. So let's say this part, as I mentioned in the last session, probably needs to be fitted or mounted somewhere on the wall on this particular surface. So we probably would like to give it a little bit more strength. So we make sure we select model settings and go to the body and apply the solid filling on this. This top part may be not a big concern of having it strong. Let's say it's, for example, maybe it is, maybe it's not, but we can change differently those infills. And let's say we use something like sparse infill. Also with this slider, we can even fine tune or adjust the density, and also we can change body thickness or, for example, infill angle. But that's not it. So this is in Z direction. Basically, it will build solid here and will build sparse here. But what if we want to have different filling settings within the same Z layer, which is normally not possible to do also by inside software. So as you see before, we have more bodies inside the part. So body number 4, it is incorporated inside the part, body number 6 and body number 5. So let's say we want to have our main frame as light as possible, and just to increase the strength and make it more solid on some spaces inside. So let's choose this part and make sure it's on solid. Just to make things more interesting, let's, for example, leave it again as a solid, and let's make changes here a little bit. So we can change the same infill density by a little bit, and let's say we want to have a body thickness a little bit higher and have more contours around it. And by changing all the bodies, giving them different settings, when you go back to the slicing and show the model, how it looks like, you will notice that the different regions of the parts have different fillings. So you can, this of course is just an example, but you can play with creative constructing of the CAD data and the different bodies to make the parts variable density. Also, addition to that, I would like to show you a little bit about inserting the pores, because we spoke that we would like to insert some metal nuts inside these slots right here. So we probably need to insert a pause, and the operator, when the printer stops, can open the door, insert the nut, and press continue to print. So you see there we have an opening where normally it should be left open just before it starts to close right here. And we go onto this layer here. Here we would like to insert the nut, but if you hover over the Add Z Pause button, it says printer with pause at the start of layer 65. So this means this layer won't be printed. Given this setting, we would like to go one layer above to have the previous layer fully printed and adding the pause before this layer would start to insert the nut perfectly. And you can notice this from the left slider here, that this diamond shape would show you on which layer the pause was inserted. You also can have a multiple. If you have in Z height multiple inserts, you can add multiple Z poses, or even use to change it, for example, material change to the different color, not the different material, but for example, different color if you use ABS or ASA. So that's it from my side from GrabCAD Print demo version. I wonder if we would have any questions from the audience.
So far, no question about that. No.
All right. Good. Thank you, Michael. So let's continue. And for a further topic, we have post-processing. So there are many post-processing techniques used with the FDM parts to improve surface quality or mechanical properties. We won't talk about them all. I just briefly go into the topic. So normally thinking about post-processing ahead when creating a model can really help to speed up the process. So let's take a couple of them as example. So if the model needs to be sanded or used with mass finishing technique, you have to think about details. For example, if you have thin tool features, you might want to modify them or eliminate completely if possible, because if used with mass finishing, the media can damage those thin features, or when it's sanded, it will be hard to get into the places. Normally, as a recommended rule, aspect ratio of 4:1, speaking about coming from the side, is recommended to have as a small thin and tall feature. Again, when sanding or mass finishing, you will be removing material. So if you absolutely need to have perfect dimensions, typically 0.04, 0.008 millimeter per surface is what will be removed. So the offset would be required of that amount when the precision is needed. Also ask for the if you have access to the printer yourself, that's good, then you are in control. And if you're asking operator to print the part, try to ask for finest slice height and optimal surface orientation in order to give the person who will be sanding and finishing the part a smooth surface as possible. Also, you would like to avoid stair-stepping effect, as we spoke in the first session. You want to reduce or eliminate curved and angled surfaces parallel to XY planes if possible. So next we talk about just briefly into the composite tooling. And when we look into the composite tooling, first thing what comes, we have two options and to build the parts, to build the tools for that. We have sparse and shell type tools. So the shell style has advantages of FDM by using the least amount of material without normally sacrificing the tool performance and result in good quality. So in many cases, you only actually need to print the layup surface which will be used with the tool. It is also recommended to have around 7.5 millimeters as a tool thickness, which could provide balance between tool rigidity and material consumption. Another option, we have a sparse styles tool. So this is something when you require Certain designs would require additional strength, particularly if you have large or multi-segmented tools. So sparse tools have a sparse infill pattern for additional strength and rigidity. So if we next, what we need to think about is also something called CTE, coefficient of the thermal expansion. By exposing tool to the heat when curing the tool, it will change dimensions slightly. So there's something you need to be considered when scaling tool if you want to have a perfect dimensions. Something like draft angles should be considered when designing female tools to avoid it locking the part inside after the tool curing. Also, if you have larger parts, consider sectioning and bonding rules from the previous section for the best assembly for the whole tool.
Carolus, one thing, as you know, I'm not from FDM side, so this is a lot of information for me, and I'm very bad on memorizing that. So is there any area where I can find this information, or even more detailed if I want to?
For sure, Michael. So this is probably would be a topic for another day. If you want to learn more on how to design and prepare tools for composite layup, feel free to register to Stratasys Academy. If you own one of our printers, there you will find under one program, under post-processing program, a deep dive guide consisting of hundreds of pages called FDM for composite tooling, and there you will learn anything from start to finish how to produce those tools. So please register to Stratasys Academy and you will find this document there if you are interested.
Great, thank you.
So next I just jumped. We will talk a little bit about texturing. So FDM isn't usually picked at, as a end-use part for its visible layers and layer lines and overall surface quality, but you can improve it with texturing and quite a lot. So in some cases reduced also the post-processing time, as coatings and paint can be applied directly to the textured surface to create a finished part. But first we have to think about the angle in which textures might be printed. So as you see from the left image, small angles between 0 and 40 degrees are not ideal. Vertically printed textures will look the best. Depending on the detail of textures, we might need to consider printing them with a finer slice height. So if you have small detailed textures applied to the part, you want to choose the smallest possible slice height in order to able to produce them. Also, by using textures, we can improve a stair-stepping effect quite a lot. So on the left side, you will see an textured sphere, and you clearly see that stepping effect, those lines. And on the right, it's textured sphere, and it hides it quite well, not perfectly, but if you look at the part visually from a little bit further away, you will notice a huge difference. Again, if you want to know more about how to create texturing patterns on FDM parts, feel free to register to Stratasys Academy. You will find the detailed guide how to do that there. So to summarize this session, as you may notice already, FDM will give you this unique ability to change the part density, have it filled with a different percentage. Using GrabCAD Print and original CAD data, we can create variable density parts to save printing time, or example, material usage, depending on what you need and what is your application. Also change model strength in specific areas, and also you can work with holes. You can improve strength for drilling, or if you want to use inserts. So again, some post-processing methods require specific design changes. You've probably seen if you will want to remove some materials, so you might to consider adding it beforehand and preserving smaller details, smaller features. You may need to think about that too. And last, so you saw quite clearly, if you have to worry about something like stair stepping effect, or you want to improve the visual appearance of the part itself, texturing is a good way which can hide all those layer lines, stepping, and improve overall appearance of the model. And so we are coming back to the full circle. In order to successfully design for FDM technology, you need to know those pillars of the process itself. You need to know how operator will prepare the model for printing. It's good when you are yourself can operate the printer, have it next to your desk, so you can do this by yourself. But in many cases, you might want to help him and guide to what results you are trying to achieve. There are some advantages and limitations also for FDM technology. Layering process might provide stair stepping with certain angles. You need to be careful with thin walls and always look for self-supporting angles to improve this. So even how the parts will be finished might affect your design in a certain way, as you saw from the few examples before. With this, I would like to thank everyone who participated or watched recordings of Design for FDM webinar series. I hope it was interesting for you and you learned something new. And I'm looking forward to see you in our future webinars and trainings. Thank you very much.
So thank you, Carolus. Before we finish this webinar, we will just open another round for questions. So if you have any questions, feel free to type them in now, because right now we don't have any other ones. But I have something from my side, since I know a little bit about texturing. I guess you can use any design program what you normally use for creating bump maps or displacement maps to generate these textures, right?
Well, I'm not sure about every programs, but I assume you can. For example, I'm using SolidWorks myself, and since 2019 version and 2020 version, there's an actual update to create. You can choose from the library already pre-created 3D textures. The one negative side, what I must say, and if you look at the guide later on, you will have to transport those textured files as STL files later on. So you will lose that ability of CAD data. But if you are considering only about surfaces, then yes. And basically creating bump maps, you can apply this, I think pretty much with every CAD software, right?
Yeah, sure. And design programs too, like Blender, Photoshop, and so on. As long as you come out with an STL, that's fine.
So if you want to learn more about texturing, feel free to watch Michael's webinar. I think he has additional training, and you can find additional information on Stratasys Academy too.
Sure. And that brings us to our last topic. So if you want to learn more about any kind of machines we have, if it's FDM or PolyJet, you can find a lot of learning path and recommended learnings in our Stratasys Academy. As you can see here, an example from the Design for FDM program. I think that one is a tutorial from GrabCAD, I guess. Is it right, Carolus?
That's right. So it's a 3-part tutorial on how to 3D print jigs and fixtures. And if you want to learn more of how to transform the part looked on the top left corner to the bottom left corner, feel free to look at that 3-part tutorial.
Great. And a good combination of PolyJet and FDM, because you create a jig with FDM to polish a PolyJet part. That's a good thing.
That's right.
And with this, I would like to say thank you to all the audience. Thanks for watching the webinar, and feel free to watch the recordings from the other webinars and of course this one on our Stratasys Academy. And see you next time on the next webinar or training. Thank you very much. Bye.
Thank you very much from my side. I wish everyone a pleasant afternoon and goodbye.